Your book is an alternate method for tackling these linear coefficient equations, and it's lesson 8C on page 66. So I thought I would just outline it briefly here. Here's a problem, and instead of looking for the intersection points of these two lines, we can do this substitution. We let u equal to this linear coefficient and v equal to that linear coefficient. And let's see what happens. The du will be 3 dx plus 2 dy, and dv is going to be dx plus 2 dy. And I got a little ahead of myself here. We're going to need this substitution also, but not quite yet. Alright, so what do? Well, we have to solve for, in order to make the substitution, because right now what I have is u dx minus v dy equals to 0. So we have to substitute for dx and dy. To do that, we have to solve this system of equations for dx and dy. So let me erase this little piece here. Then we'll let me put this under here. dv equals to dx plus 2 dy. I just transfer this over. And now if we subtract, I'll put a negative in front of these, same as multiplying by -1. Then we're going to have du minus dv equals to 2 dx, and the dy's cancel. Alright, so dx then will be du minus dv divided by 2. And now we have to also solve for dy. So I'll go back to this system of equations, and now I'm going to eliminate the dx terms. So I'm going to multiply this equation here by -3, so I can eliminate the dx's. So that gives us, I'll rewrite this one, du equals to 3 dx plus 2 dy, and then -3 dv equals to -3 dx minus 6 dy. Alright, so now we have du minus 3 dv equals to, these cancel, -4 dy. So if I divide by -4, I get dy is equal to positive 3/4 dv, so 3 dv over 4, and then minus du. Tell you what, I'm going to put all that over 4. There we go. So I've come up with these substitutions. So you have to ask yourself, is this better than the other one? I don't know. It's kind of a matter of a taste, isn't it? Alright, so let's go back to our original problem here. Put in these substitutions. And let's see what happens. Okay, I've substituted the dx and dy back into this equation, and also using u equal to this term and v equal to that term. And this is what we have. Now I'm going to multiply everything by 4 so we can cancel out the denominators, get rid of those fractions. Multiplying by the 4 gives us 2u, parentheses du minus dv, minus v, 4 is canceled, times 3dv minus du. Alright, so let's see what we got now. I'm going to separate the du terms. So I have 2u du here, and we have minus v du minus v. So that's our du term. And then we have, let's see, plus, we have negative 2u dv, negative 2u, and then another dv term is minus 3v, and that's dv, equals to 0. So what we succeeded in producing is an equation with homogeneous coefficients. In other words, in a sense, we eliminated the constants. However, the coefficients did change from here, as you can see. All right, well, at this point, you would probably let's see, what was our substitution? We need another variable, right? Since we have u's and v's, I need an extra variable. How about t equal to u over v, which means that u would equal to v times t. And then take the differential of this equation. We have du equals to v dt plus t dv. Alright, so now I can substitute this part right there, and of course do these substitutions, and I think I'm going to leave the rest to you. It's tedious no matter how you look at it, but this is a different approach which I think was really worth taking a look at. So I'll leave it at that and leave you to finish this problem. I think it's probably pretty routine from here, albeit tedious.